We are now about to dive into the world of semiconductor design. And for this, I'm here in the semiconductor vertical with our Director of Marketing, Neil Hand. Hi, Neil.
Hi, Max. Nice to be here.
Okay. So, Neil, what do we actually mean when we talk about software-defined systems?
It's a good question. If you think of traditional product design, the world of software and semiconductors is largely abstracted from the design itself. You think of, I'm going to have a car, there's the engine has an ECU, and you don't really worry about the co-design aspect. With a software-defined system, the software and the silicon that it runs on defines the overall form and function of the system. So you can't do them separately. Everything has to be combined. The mechanical, the electrical, the semiconductor, the design is all brought together into one seamless process where you're tracking throughout and optimizing and co-designing the whole thing.
Okay, now why do, or maybe should, people actually care about semiconductors?
If you like anything you do on a day-to-day basis, you are interacting with semiconductors, whether it be complex devices like your cell phones, whether it be just connections to the internet or connected products, even price stickers in the supermarket that have embedded RFID tags or your hotel room keys. Semiconductors are everywhere. And the need for semiconductors is growing as we build more and more connected products, as we have more and more interfaces we need to work with in the real world, and as we need to drive towards sustainability. Because if you think about a lot of the sustainability initiatives, a key theme of the show here, it's about smart cities, smart infrastructure, smart batteries. And you can't have smart without semiconductor and software. They're intricately linked. So semiconductors are a fundamental part of everything we do in our daily lives.
And very briefly, Neil, what are the innovations that are driving this change at the moment?
There's really, say, three key things. One is just the constant drive of technology in Moore's Law, with complexity increasing every 2 years, and the need to support more and more technology. There's new technologies we're talking about at the show, like 3D-IC, where you can start to assemble devices and go more than more. So you can have incredibly complex systems built really simply and easily. And then, of course, there's AI. AI is everywhere. And AI is changing not just the needs of the semiconductor devices, but how we can help customers build products that have semiconductors inside them and build end-to-end seamless infrastructures.
Okay. Thank you, Neil. Thanks for your time, and thanks for doing promo for 3D-IC, because I'll be speaking to another colleague about that later on in this very spot.
Okay. Have a good day.